I wanted to offer you a little bit of assistance when it comes to doing these Ohm law problems. We've talked about Ohm's law, but a quick review. Ohm's law is very important because it describes the relationship between the electromagnetic force and the means at which to move electrons. So for example, I like this little cartoon because it illustrates how volts pushes the current. Amps is the measure of the current itself, or the work being produced, and ohms is how much resistance or push back against the electron flow that you have. And we've talked about that in detail, but just a reminder, the relationship between ohms, volts, and amps. And an additional reminder, going back to our will, and we'll talk about how to use these in a second, that in the HVAC world, we measure the current in amperage. Unfortunately, the electric company will measure and charge customers based on their usage in watts. So it's important to be able to convert amps, or I in our case, to watts or W to describe usage. And the company will measure usage in kilowatts or thousands of watts. So 10 kilowatts, 10,000 watts. Talking about heaters, common examples of measuring the current in heaters. They go in 5 kilowatt sections. So 5 kilowatt heater pulls 20 amps. 10 kilowatt heater pulls 40 amps. 15 kilowatt heater pulls 60 amps. 20 kilowatt heater pulls 80 amps. Those are the most common in the HVAC side. In the refrigeration side, you're going to use much smaller heaters that will pull anywhere from 2,500 watts or 5,000 watts. That'll pull 5 amps, for example. But it's important to be able to convert that amp draw to wattage to describe to the customer in terms they're more familiar with. Now, when we're looking at our Ohm's will, we have two wills that states if you have any two values in this relationship, that you can find an unknown value. So in our first will, we have volts, amps, ohms, or in this case, EIR. In our other will, we have watts, volts, and amps. If you have any two, you can figure out the third. And let's do a couple quick examples. So for example, you have an air handler using 240 volts and a 20 kilowatt or 20,000 watts in your heaters, usage in your heaters. How many amps will the air handler use when all 20 kilowatt heaters are running? Good question. Over here, if we look at our calculator, and let's pull our will back up actually. So, first thing you want to ask yourself, what two values do I know? I know that I have 240 volts, okay? And I also know that I have 20,000 watts or 20 kilowatts. So I have voltage and wattage. And now I'm trying to find my amperage. If we go to our will, voltage and wattage. So if we take the watts divided by the volts, it will give us our amperage. Do you see how this will works? I plug in my 20,000 watts divided by my 240 volts, and I will get my amperage. So I'm going to pause for a second and let you pull up your own calculator, either on your phone, and try to get an answer. I'll give you 10 seconds. Okay, so let's try this here. Watts divided by volts will get us our answers. 20,000 watts divided by 240 volts equals 83.3 indefinitely for infinity watts. If you remember, rule of thumb, 20 amps per 5,000 kilowatts. So 20, 40, 60, 80 is how I would describe it. You got 80, but if you want to be more precise, we're pulling 83.33. So your answer here, let me see, would be 83.33. Not very good with drawing with a mouse. Let's try another one. If a 240 volt blower motor is pulling 3.2 amps, what is the ohms rating? Or if you have 240 volts pushing and you have 3.2 amps of power, of current being used, what does that tell us about the resistance of the motor, of the windings in the motor? So let's look at our wheel again. We know we have 240 volts, we have 3.2 amps, so 240 volts, 3.2 amps, and we're looking for R. So if we go to R here, volts divided by amps. Volts divided by amps. So I hope you're rushing ahead of me here. Volts divided by amps, 240 divided by 3.2 equals 75 ohms of resistance. And feel free to verify this on a heat pump or an air handler heat kit back here when you're testing a blower motor. So I've already forgotten. 75 ohms. If you have any two, you can find the third. Let's do one more. How much is an air handler consuming in terms of watts? You have to be able to make that distinction yourself. How much is an air handler consuming if it's pulling 60 amps at 240 volts with 240 volt supply? 60 amps with 240 volt supply. Get our wheel. We want to find watts, so we're going to find the W. And we have volts and amps. If we take E times I, what is that? Volts times amps. So let's get our calculator. Volt times amps. Okay. Clear. 240 volts times 60 amps. How many watts are we using? That would be 15,000 kilowatt heater. Or, more precisely, I'm just giving you a rule of thumb. They usually call them 15,000. To be more precise, 14,400. The circles are the hardest. Now, I'm going to ask you to answer several questions like these where I give you two values, you find the third. If you have any questions, let me know. But just remember that when you're dealing with customers, if you talk to them in terms of amperage, they have no idea what you're talking about. You talk to them referencing watts, they pay that bill every month. Their ears will perk up and they'll listen very closely. So it's important, although we test an amperage, to be able to convert that amperage to watts.